Good morning. Today we are going to talk about coefficient of determination and F ratio. But before starting the new part, we have to make sure that you understand how to estimate the parameters and test the hypothesis, test the significance of these parameters. So let's take an example and then calculate the parameters and test the significance of these parameters in this example. Say for example that summation, if you know that summation x is 38 and y is 77, x bar is 30 is 5.43 while y bar is 11. Summation xy is 342 and summation x squared is 256. Number of observations equals 7. Summation small x squared equals 49.7 and summation e squared equals 11.82. Required: number 1, estimate the parameters. Number 2, test the significance of the parameters. If you know that y hat equals a hat plus b hat x, so we would like to estimate the parameters or get the value of a hat and b hat. Let's start with b hat. B hat is calculated as xy bar minus x bar y bar divided by x squared bar minus x bar squared. So at the first step, we have to calculate xy bar and the x squared bar. It's calculated as xy divided by n, and with respect to x squared bar, it's calculated as x squared divided by n. If you know that n equals 7, so we have to divide summation of xy divided by 7 in the first one, and in the second one, summation of x squared divided by 7. So it will be 342 divided by 7, and in the second case, it will be 256 divided by 7. So if we find that x squared bar equals 36.57 and xy squared xy bar equals 48.86. Now we can substitute in the equation to find the value of b hat. It will be 48.86 minus 11 multiplied by 5.43 divided by 36.57 minus 5.43 squared. So the value will be negative 1.53. Now we would like to find the value of a hat. A hat is calculated as y bar minus b hat multiplied by x bar. So y bar equal equal 11 minus negative 1.53 multiplied by 5.43. So A hat will be 19.3. So we can write the equation as Y hat equals 19.3 minus 1.53x. This is the estimated equation of Y hat. From this equation, we can interpret the results as this equation studies the relationship between x and y, where y is the dependent variable and x is the independent variable. If x equals 0, y will be 19.3. If x increases by 1 unit, y will decrease by 1.53 units. Now we would like to test the significance using t-test. We would like to test the significance of B and then to test the significance of A. Testing significance for a parameter is based on T ratio. So T in case of B hat is calculated as B hat divided by standard error of B hat. And the standard error of B hat is calculated as square root sigma squared divided by summation small x squared. Where sigma squared is calculated as summation e squared divided by n minus k, where n is the number of observations and the k is the number of parameters. So now we would like to substitute in sigma square in order to find sigma, then substitute in standard error, and then substitute in the T ratio. So sigma squared is calculated as summation e squared, which is 11.82, divided by summation x squared, divided by n minus k, where n equals 7 and the k equals 2. So sigma squared equals 2.364. Now we can substitute in standard error equation. Where sigma square is 2.364 and summation small x squared is calculated as 49.71. So we can get the value of sigma squared as 0.22. Now we can calculate the value of T as B hat divided by standard error of B hat, which is negative 1.53 divided by 0.22. So it will be negative 7.01. So in this case, we are going to accept H1 and reject H node, which means that X has a significance impact on Y. X has a statistically significant impact on Y. Now we would like to do the same with respect to parameter A. T ratio is calculated as A hat divided by standard error of A hat and the standard error of A hat is calculated as square root of summation x squared divided by n multiplied by small x squared multiplied by sigma. Sigma is calculated as the square root of sigma squared, which is 1.54. Summation x squared equals 256 and summation small x squared 49.71 and n equals 7. So we can substitute in sigma squared and standard error of E hat as 256 divided by 7 multiplied by 49.7. This is multiplied by 1.54. So it will be 1.32. So now we are going to substitute in T. A hat is 19.3 and standard error is 1.32, so it will be 14.6. From this we can conclude that we are going to reject each node, which states that the variable has no significant impact on Y, and accept H1, which means that there is a significant impact. T ratio is related to testing the significance or reliability of parameters. Now we would like to test the validity or reliability of the model itself. So we can use two different measures. They are coefficient of determination, also known as R squared, and F ratio. Regression analysis shows the best fitted line. This line is the best fitted line. It doesn't reflect reality, but reality is scattered points around this line. If true observations lie on the best fitted line, so this is perfect fit, but actually we couldn't reach the perfect fit point. If it's like these points, so this is known as perfect fit. But actually, we couldn't reach the perfect fit. But actually, we reached best fitted line. So we would like to minimize the error. We would like to make small residuals. It's known as residual or errors, they are the same. The word residual means error. So we can explain the idea of coefficient of determination using Venn diagram. Let's assume that this is y, which is the dependent variable, and this is x, which is the independent variable. And these are different models. All of them shows the relation between the actual and the estimated, or the true value and the estimated value. In all cases, there's a relationship between x and y, as one of them is a dependent and the other one is independent variable. So for example, in number A, r squared equals 0, which means that there is no doesn't explain y or has no impact on y. While with respect to A, B, C, D, E, with respect to E, r equals 1, which means they are identical to each other. They are perfect fit for each other. So this is the two extreme cases, either 0, which means that there isn't any relation between x and y, or 1, which means that x explains 100% of the variation of y. Also, there is varieties represented by B, C, D. Say, for example, B can be 0.3. This means that x explains 30% of the variation in y. And say, for example, with respect to C, it's 0.7. This means that x explains 70% of the variation in y, etc. So this means that r squared shows the percentage explained by the model, the percentage of the variation in y explained by the model. So coefficient of determination, or r squared, represents the proportion of the variation or a change in the dependent variable y that explained by the variation in the independent variable x. So we can divide total variation into explained variation and unexplained variation. We are going to use a different names than total variation and explained variation. So total variation will be known as total sum of squares, TSS. And the explained variations are known as explained sum of squares, or ESS. And the unexplained variations is known as residual sum of squares, or RSS. So we can write it as TSS, which is total sum of squares, equals estimated sum of squares plus residual sum squares. How to calculate each one of them? Total sum squares, it's calculated as small y squared, or in other words, y minus y bar squared. And ESS is calculated as the estimated value of y minus y bar squared. While with respect to residual sum squared, it is calculated as summation E squared. So now we would like to calculate the percentage of the total that has been explained. So R squared can be calculated as explained sum squared divided by total sum squared in order to find the percentage of total variation that has been explained by the dependent variable. Sorry, by the independent variable. Or we can write it as 1 minus residual sum squared divided by total sum squared. So let's return back to our example and calculate R squared in our case. As we said, summation E squared equals 11.82, and summation small y squared equals 77. Sorry, equals 128. Equals 128. And finally, with respect 2 y hat minus y bar squared equals 116.8. So now we can use these data in order to calculate r squared. If you are going to add 116.18 plus 11.82, this is the ESS plus RSS, you can find the value of TSS, which is 128. So now we are going to substitute in r squared in order to find the value of r squared as 116.18 divided by 128. It will be 0.91. So this means that the dependent variable, the independent variable explains 91% of the variation of y. So this means that x explains 91% of the variation in y. This is with respect to r squared. What about f statistic or f test? F ratio is another statistic that indicates the overall significance of the regression. So here we would like to test a null hypothesis that A equals B equal 0. So this means that the model is insignificant. Not only a single parameter or variable just like t, it is for the whole model. And H1, A not equal, B not equal 0, which means significant. F is calculated as r squared divided by k minus 1 divided by 1 minus r squared divided by n minus k. So we can write it as 0.91 divided by k minus 1. Number of parameters are 2. So k minus 1 is 2 minus 1, which is 1. Divided by 1 minus 0.91 divided by n minus k, which is 7 minus 2, which is 5. So F statistic will be 49.2. So this means that the model is significant.